Hello and welcome once again. Today I am going to discuss about the linear probability model. It is in short form LPM using Minitab software. So let me explain what is linear probability model first. After that, how can we estimate this model, this type of model, and how can we explain this model. So, and with an empirical example, hypothetical example will be given to analyze this model. Okay. So, as far as the definition is concerned, linear probability model or LPM is a multiple regression model with a binary dependent variable, and it is linear in parameters. So far we know that the dependent variable generally is quantitative in nature but there are so many examples in the real world situation when we see that the dependent variable is binary nature. That means yes, no situation arises with the dependent variable. In that type of case or cases, we can define that if we formulate the problem in terms of a regression model, then this is known as linear probability model. And for linear probability model, we can easily apply the ordinary least square technique, and our interpretation will be little bit different from the other or general type of regression, linear regression or multiple regression model. As we know, in multiple regression model, we explain the estimated regression as the impact of dependent variable with the 1 unit increase of the independent variable, keeping other things unchanged. But in this case, in the LPM, we have to explain in this way that it is the change of the probability of the dependent variable in favor of success. I am explaining what do we mean by success later on. In favor of success for a unit change of a independent variable, keeping other independent variables are unchanged. Now, the example of success, what do we mean by success? Success depends on the variable of the study. For example, when our dependent variable consists of smoker or non-smoker, then success may be defined as smoker. Similarly, whether a married woman is participating in a labor force or not, so success may be if she is participating, then success is labor, that married woman is participating. Similarly, sanctioned or not sanctioned loan, success may be defined as the sanctioned loan. If you ask whether you are willing to buy a car or motorcycle, then success is yes, no means another thing. Similarly, after 10th standard examination, which stream a student opt for, science or not? Success may be science. So all such kinds of problems, the answer lies between yes or no. Hence, these are the examples of LPM which we can estimate through the OLS. Now, I am giving how can we formulate such kind of model. Suppose you are planning to investigate what are the factors responsible for smoking. So, you have to take smoker as dependent variable, and which may depend on some independent variable. Let us assume these independent variables as age, one of the important factor, similarly education, similarly income of the respondent, similarly gender, similarly location, whether it is a rural area or urban area. So we are assuming that these factors may be responsible for taking the decision of smoking. This is an hypothetical example. Therefore, your regression equation stands for like this: smoker, dependent variable, this is intercept alpha 1, alpha 2 age, alpha 3 education, alpha 4 income, alpha 5 gender, alpha 6 location, and the error term. There may be some other variable which are not included here, which may capture in the error term. Now, through primary survey, you can collect the data. For dependent variable, put 1 if the respondent is smoker, otherwise put 0. Similarly, for other categorical variable, if the two categorical variables in the independent variable as independent variable, one is gender, put 1 for male. Similarly, put 1 for urban area. or 0 for rural area. So 0 for rural area. Now after collecting data, put your data in the Excel and save it and give some name of the file name. Now go to Minitab. I'm going to Minitab Software. This is Minitab Software. Okay, how can you import the data? Suppose you have kept your data in desktop. This is your data, and you have given the file name as smoking data. So you have to import this data into your software. How can you import? Okay, open the software, go to file, go to open worksheet. Okay, now this is my documents. Go to desktop. Here all files, click all files. Then from desktop you have to collect the information. File name smoking data, write smoking data. Okay, open. Smoking data is automatically it has come into the software. Okay, now you go to stat regression, fit regression model. Whenever we apply OLS, we can run regression in this way, fit regression model. Okay, now you have to put the responses, that means dependent variable. Smoker is select. Okay, now come to continuous predictors. Age, continuous predictor. Similarly education, continuous predictor. Similarly income, maybe continuous predictor. Now come to categorical predictor. Is gender, because male or female, 1 or 0. Similarly location, urban or rural. If urban, 1, otherwise 0, select. Okay, if you want to plot the graphical also, you just give it 4 in 1. Okay, so click OK, you will get the result. So graphical option I will explain later on, but for this moment you just, how can we explain? This explanation is very, very important. You look, regression analysis, where smoker versus these are the independent variable, and the categorical predictor 1 0. Predictor is 1 0. That means dependent variable depends on binary number 1 or 0. If smoker 1, otherwise 0. Analysis of variance at this moment is not needed. We can start from the coefficient. Look, these are the coefficient, standard error, t value, p value. So from p value we know that since 0.03 is less than 0.05, so this is significant. That means age is significant and education is significant, and other values are not significant. It implies age is negative, coefficient is negative, and education is also negative. How can we interpret? That means with 1 unit increase of age, that means 1 year increase of age, the probability of smoking declines by this extent. Similarly, with 1 unit increase of education, the probability of smoking declines by 0.04. So in this way we can explain. And other things, that means income is not significant, but here it is also showing that with the increases of income, people's propensity or probability of smoking declines, but we cannot say that this is statistically significant. Similarly for gender, if it is 1, that means for male, though it is positive, there is some tendency to increase the smoking probability if the respondent is male, but this is not statistically significant. Similarly, there is positive association that the location, if it is urban area, then the probability of smoking increases, but it is also not significant. Only 2 significant independent variables, one is age, another is education. Now this is the group of regression. 4 groups are there. 0 0 means female and rural area. Similarly female urban, male rural, male urban. In these 4 groups, 4 type of regression models are here. Here the coefficients are same. We have to compare only the intercept. With respect to intercept value, this is the smallest, 1.461. That means there is the least probability of smoking if the respondent is female as well as staying in the rural area. Though it is easy to estimate, but there has some limitations or some problems for such kind of model, linear probability model. Explaining this problem, look, this four diagram shows that first one is shows the normal probability plot. It shows the data has been taken from normal populations. Another one, the fitted value shows that, look, this value is fitted value maybe this value showing showing the value is more than 1. Look, the fitted value 1.27. Similarly, this fitted value is 1.3778. Similarly, this one is 1.18. So since fitted value means the value of the dependent estimated value, and since the estimated value or the dependent value is the probability, it means the probability is exceeding more than 1, okay, which is absurd. We know the range of probability is greater than 0 but less than 1, less than equal to 1, greater than equal to 0, the maximum range. So in this type of model, the fitted value may be negative or may be greater than 1. So this is not possible in the real world situation. Similarly, the residual is not showing the normality, so error terms are not normal. Another problem is, since this is linear in estimation, it means that whatever may be the initial level of the value of age or education, with 1 unit increase, the impact on the dependent variable, that means probability of decline of smoking will be same if the age increases from 19 to 20, or from 59 to 60, or from 69 to 70. Whatever may be the change, 1 unit change, whatever may be the initial level of age, but with the increase of 1 unit increment, the impact is same. Similarly, if the education increases from 0 to 1, the probability of smoking declines in this way. Similarly, if the education level increases from 15 to 16, the probability of declining smoking is same. So these are the problems. Similarly, the error terms are also heteroscedastic in LPM. Hence, we have to apply the T statistic, F statistic, etc. with very cautiously. Okay, so these are the limitations for LPM model. So thank you.